Hi, this is Mr. Heichel bringing you another little quick video. This time we're going to talk about ionic naming and writing formulas. So we did covalent bonding and writing formulas, and it was really pretty simple because we looked at the prefixes or the suffixes or the subscripts, and we could easily name the covalent molecules. So ionic compounds are a little bit more difficult. You got to really know their oxidation state or the charge that they want to become after they either donate or they gain electrons. So the first step is you're going to write the cation. And if you remember, these are typically metals. And then you're going to write the anion, which are going to be our nonmetals. And then we're going to use the IDE ending. So everything needs to end in IDE. The major difference between naming covalent and ionic compounds is ionic compounds do not use prefixes. So you're never going to have a mono, a di, a tri. You're never going to have any of that whenever you are naming or formula writing for ionic compounds. So let's start with these first four. One of these is going to be unique, and then I will get there, explain why it's unique whenever I get to that one. So first of all, I would want to know if I was naming these, is I would want to know if they're binary or ternary. So remember from the other lecture, binary means two. It only has two elements. Ternary is going to have three or more. So if we look at this one right here, that's got three elements. It's got a potassium, a phosphorus, and an oxygen. So we're going to get to that. We're going to save that one till last. So let's look at these other three. If I look at Li is lithium, so I simply write lithium, and then I write oxide. No prefix. I don't have to put dilithium. I just put lithium oxide. The next one is also binary. So Ca is calcium. And then sulfur. Instead of putting sulfur, you're going to change the ending to a sulfide. Again, the I just means that it's bonded. It just sounds better. We've got Mg2Br. So we've got magnesium. And then Br is bromide. So on this one, I said it was special because we have what's called a PO4. This is what's called a polyatomic ion. And I'm going to give you a chart that's going to have all your common polyatomic ions on it. And I like this chart because it gives you the charge at the top and it gives you all the names. So it's really easy to figure it out. You're not going to need to memorize this chart. I don't believe in memorization. I believe in application. As long as you know how to use the chart, we are good. So we see a PO4. We see this PO4 right here. We see this PO4 right here. A PO4 is going to be a phosphate. If you're ever in doubt, the 8 is going to be larger than the ite because it ate it. So it's going to be a little bit larger. So this is going to be potassium. And then we find that PO4, which is going to be phosphate. So it's really simple. Really simple at this part. We don't have any transition metals. We're going to do transition metals on Monday. But as for now, we're going to stick with this. So now we're going to write formulas from the names, which is a little bit more difficult, but not too bad. So now we've talked about making ions. Remember, gaining or losing, right? So the metals want to lose. The nonmetals want to gain. We got to determine the charges. That's the first step. So we know that sulfur, so this is a bond between sulfur and lithium. We know that sulfur creates a -2 anion because it gains two negative charges. The lithium is going to lose a +1 charge. So it's going to become a cation. And then what we're simply going to do is we're going to take these numbers and we're going to do what's called these swap and drop. We're going to switch the numbers and then drop the plus and the minus. So that arrow's already done for you right there. The lithium, you're going to have 2 of them because sulfur had 2, and you're going to have 1 sulfur because the lithium had a 1. So you're going to swap the numbers and drop the signs. Does that make sense? If it is the same charge, so if it's a +1 and a -1, you're just simply going to not write the numbers. They're going to reduce to their lowest form. So let's start with strontium and fluorine. Strontium is Sr. It's in group 2, so it has 2 valence electrons. So it wants to lose both of those valence electrons. When it loses those 2, it becomes a +2. Fluorine is in group 17, the most electronegative chemical on the periodic element on the periodic table. So when it wants to gain 1 from anything and create an anion, that's a -1. So what we're simply going to do is we're going to take this 2, we're going to put it on the F, we're going to take this 1, we're going to put it on the Sr, and our formula is going to become Sr F2. Not too bad, right? Sr F2. So let's start another one. Nitrogen and magnesium. So magnesium is going to be our cation. It's just like strontium. It's going to be a +2 because it has 2 valence electrons, and it's easier for it to lose those 2 than to gain 6 to get to 8. So our nitrogen is in group 15, which means it has 5 valence electrons. So it wants to become an anion and become -3. So we're going to take these numbers, we're going to switch them. The 2 is going to be on the N, the 3 is going to be on the Mg, so we're going to have Mg3N2. Very good. Next one, we've got hydroxide and aluminum. So hydroxide is one of those polyatomic ions. It's going to be OH. There is no hydroxygen on the periodic table. So when we look at -1 column, we got a hydroxide. We know the hydroxide is a -1. So that's going to be our anion. Aluminum is in group 13. It's got 3 valence electrons. It wants to become a +3 cation. So we're going to take the numbers and we're going to flip them. So we're going to have Al, put a parenthesis since this is a polyatomic ion, OH. That means we have 3 OHs. Not 3 aluminums, just 3 OHs. And the last one, sulfate, is also on the polyatomic ion chart. So if it ends in an ATE or an ITE, it's going to be a polyatomic ion in this class. So we're going to find sulfate. Sulfate is going to be in that -2 column. It's going to be right here. It's going to be an SO4, -2. So negatives are going to be our anions. SO4 to -2. Calcium is going to be a +2. It's in group 2. It wants to lose and become a cation. Since you have a +2 and a -2, you just reduce them. So you've got a Ca, put a parenthesis, SO4. Sound good? Let's look at a few examples real quick. Actually, let's not work a few examples. I will go over with you in class. We're going to start simple. My examples are transition metals, and I don't want to get to that today. I want to do that next week. If you have any questions, please let me know. Don't hesitate to ask.